How are we feeling today? Last session of the day? Yes, excellent, excellent. You brought excellent energy to this time of the day. I really appreciate it. So my name is Adele Carpenter. I'm a software engineer at Trifork Amsterdam. Most of my day I do spend building and maintaining Java and Kotlin applications for the educational sector, although more and more lately you will find me trying not to cause too much damage with React in the front end. So has anyone here seen a talk from me previously, either in person or online? Oh, excellent. A couple of fans in the audience. Welcome back. That's really cool. Thanks to everyone for choosing to attend this session. So I do hope that you enjoy listening to it as much as I enjoyed writing it. So I have spoken before about rewrites, and I use the example of Lika, a junior engineer who has just joined a team working on a large and aging Java project. And she's feeling overwhelmed at the sheer enormity and complexity of the project and feels that the only way out of her current nightmare is a rewrite. But luckily she is surrounded by an awesome team, and they help her to see that a rewrite is rarely a good choice. And as a team, they decide that they're going to move the project forward by taking small, consistent steps in the desired direction. And I 100% stand by that talk and that advice, but it got me thinking, is there ever a time when a rewrite is a good idea? And it turns out that it was a little bit serendipitous because around the time that I started thinking about this, my team and I were presented with this very question on a customer project. So to give you a little bit of a background on Trifork, we are a project-based consultancy, and the team that I work with are a little bit unique in that we have a product as well, the Assessment Delivery Engine, or Exam Player, that we deliver to a small number of customers, each of which have a custom implementation on top of the core product. So basically, it can pass assessments that comply with a certain specification and then play the assessment for the student or candidate. So it renders the questions, manages the times remaining, selects the next question, and calculates the results. So we have the product part, and the custom implementation on top is the project part. So recently, one of our customers, the one with the most custom of the custom implementations, was starting to get a little bit frustrated with one of our applications. And to be completely honest with you, we shared their frustration. Now, I mentioned already that one of the features of our product is that it selects the next question, which seems pretty straightforward, right? You have a list of questions and you pick the next one, go from index 2 in a list to index 3. Well, no, not in all cases at least. So for this customer, we actually have a dedicated web service for selecting the next question. And at the core of this is a web service. At the core of this web service is an open source C++ service written by a top researcher in the field of automated testing and computer-based student assessments. So her profile actually says automated testing, but I think for this audience, such language is a one-way ticket to a misunderstanding. And the service that she wrote is an implementation of item response theory. So item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. And the models of IRT are used to design, analyse, validate, and score assessments. So to make things a little bit more concrete, you can think of an item as a question with a certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a selection of these items. And the point of the assessment is to determine the student's knowledge of or ability related to the topic of the assessment. Now, in a standard assessment, everyone gets the same questions. And for an average student, some of the questions will be way too easy and some of them will be way too hard. You could even have some students where all of the questions are too easy, or other students where all of the questions which are way too hard, which kind of makes the assessment kind of pointless for them. So one of the cool applications of IRT is that you can estimate a student's knowledge or ability on the fly and deliver a question that is at the right difficulty for them in that moment. And this can make the results of the assessment much more meaningful. It also makes the assessment appropriately challenging and hopefully more interesting for the student. Now, I want to make really clear at this point that the C++ service was not bad. The researcher will forget more about IRT and statistical validation methods than I will ever know, but we did have some problems running and maintaining it. The service, while reliable and fast, was essentially a black box. We sent it data and it sent data back, and we did not have the skills in the team to verify the results. We kind of just trusted that it worked and select an appropriate next question for the student. Initially, there had been some simulation testing done, some validation, but that was some time ago by an external party. So adding features was just something that we didn't do out of the fear that we'd ruin the validity of the underlying algorithms. And this was a key source of frustration for the customer, that the service, while useful, was essentially stagnant. Now, in a pinch, we could contact the original researcher that wrote it, but she's a busy woman and maintaining this service is absolutely not her highest priority. Now, adding to this, the service itself was not a web service. So years ago, there had been a developer brave enough at Trifork to write a wrapper around the algorithmic call, which gave us 4 endpoints that we could call. But our only options if we got an error was just to check our request and retry. So further, logging in the core model was non-existent. So for example, if we had an item with an unexpected difficulty, which could be as simple as a typo, there was no logging to tell us what was wrong. And since the core model dealt primarily with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, which left our requests essentially meaningless. So if there was any issues with a particular item, it was almost impossible to figure that out. And because the service is stateless, we had to send the entire item bank with every single request. So about 60,000 lines of JSON and expanding. And if you were brave enough and you did decide to open the code base, you were presented with code that was written in the language of the academic domain. So it had names like these. So let's go through these names quickly. So APAR, not too hard, A parameter, but what does that mean? Item difficulty, obviously. BPAR, B parameter. In real terms, that's item discrimination. So how well does the item help estimate the student's ability? CurSeg, current segment. Not too bad, but not explicit enough for my liking. Theta, another one from academia. Theta is the ability of the student, the thing we are estimating. So now that you know theta, can you yell out your best guess for warm theta? You know what, the real answer is almost as ridiculous. So, it's actually called warm theta because warm was the last name of the guy that proposed this method of estimation in a paper. Not because it's a close guess, and not because it's for alive students, but since it's, an estimation, I guess it is kind of a close guess. So warm kind of fits hilariously. And then we can round out the list with cluster and category. Again, these are academic terms and they don't match the language that we use in the team. We use the terms friend group and domain, respectively. So I hope I've made it pretty clear so far why the current service is problematic. So it's a black box, it's hard to reason about and debug, and trivial changes take a long time and they require a steep learning curve. Now, maybe not so obvious is what makes the service a good candidate for a rewrite. So, firstly, it's stateless, so it receives data and it returns data, so we don't have to worry about a data layer or a front end. It has a well-defined scope or footprint, so we just need to expose 4 endpoints to one service only. And it is a small part of the entire project. This reduces the risks or the potential downsides of a rewrite or a port attempt. So this brings me to what, in my opinion, are the three most compelling reasons to entertain the idea of a rewrite. Now, personally, I do think that you need all three, but you would want at least two. And the reason that I would want all three is because they each look at the question of should we rewrite from a different perspective. But first, I want to start with a reason zero because, well, we're developers, so we are zero indexed by design, but also because without a reason zero, then all the other reasons are irrelevant. There is a desire to functionally change the application. So if an application is running reliably in production and there's no desire to change its functionality, then I would be hard-pressed to come up with a reason on why you would rewrite it or port it. You may see some odd behavior here and there, and investigating that when it happens is the bane of your existence for a day or two. But if those incidents are few and far between and there's no desire to change the functionality of the app, then that's probably just a reasonable cost of running it in production. As long as you can do the bare minimum to keep it running, like bumping versions when necessary and using long-term support versions wherever possible, the status quo is probably fine. And if this is the case and you still want to rewrite, you probably need to dig down a few layers on why you want that, because it's probably about you and not about the project at all. For example, you're just not comfortable being responsible for something that you don't understand well. So on to the first reason of why you might entertain the idea of a rewrite. And we're going to start looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. Now, I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to evolve your application. And there's a big implication here, though, and that implication is that the small steps are, in fact, small. So let's take the example of the bad logging in my team's project that I mentioned earlier. So a quick win would be to add some logging, right? So in this case, given that we are a JVM-based team working on a C++ service, that would require running the project locally, learning how logging in C++ works, actually learning about a lot of stuff that the JVM abstracts away, like memory pointers, identify an appropriate library, add the dependency, learn how dependency management works in C++, learn the basics of the build tool, and then pray that it runs again. Now, for some teams, maybe adding logging to this application is indeed a trivial change. But for a team that lives mostly in the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to a large undertaking? Because I think it's a little bit simplistic to say that adding logging is always a small step. And the same thing goes for other small steps, such as improving test coverage, renaming, extracting methods, or improving abstractions. Whether or not they are really small or not is up to your team to decide. It's not up to me or to anybody else. But what I can do, though, is I can offer you some advice on how you might approach these discussions. And that is to be aware of your bias and to look for evidence that proves yourself wrong, rather than having a wish and then trying to prove that it is a good idea. This will help you minimize the impact of confirmation bias in your decision-making. So for example, if you're currently feeling the pain of a legacy code base, you're probably biased towards rewriting the application in a way that is more familiar to you. And in this case, I would advise you to look for reasons why keeping the current application in production is actually a good idea. So you can ask yourself questions like, why should I keep the existing code base? And what opportunities exist to improve it? So in our case, maybe like yours, being the skeptical duchies that we are, we thought that a rewrite was really a last resort. And so we asked ourselves questions along the opposite kind of direction. So our line of questioning was more like, what pain are we experiencing that can only be resolved by rewriting the application? Are the opportunities to improve the application actually there? And how much work are they really? And is that really less work than a full rewrite or a port, given the current makeup of the team? So this brings me on to reason 2 of why you might consider a rewrite, which looks at the team in the context of the organisation. So the skills are not in the team and you do not wish to acquire them. So does the team have the skills to consistently improve the service? And if not, does the company wish to acquire these skills? So we've already established that a small step for one team could be a big step for another team. So you could be forgiven in thinking that this reason is essentially the same as the first. But the key difference here is in that last part of the sentence, and that's what I want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that are in line with your company or project's tech stack. And this is a completely valid reason for considering a rewriting or porting an application. And it certainly was a big reason for us. So at Trifork Amsterdam, probably like a lot of you here, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. We incorporate tools and technologies that are within that ecosystem, or at least very closely related. Of course, we are made up of individuals of different skill sets and different backgrounds, so there is some .NET experience, and if you do go wise and grey enough, you'll get some C++. But our bread and butter is Java Spring, and that's not going to change for the foreseeable period. We are a small company and we run many of the applications that we build, so keeping the tech stack manageable is actually a strategic advantage for us. Now, that doesn't mean that every new service that we write is in Java, especially if startup time, memory use, application size, for example, are priorities. But it means that while we do believe in the best tool for the job, or the right tool for the job rather, we also know who we are and what our strengths are, and we look for good enough tooling that is complementary to our existing tech stack. So I'm digressing a little bit here, but this is what helps us avoid the pitfalls of resume-driven development. And considering a rewrite is a time that you can see RDD come out in full force. So as the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. And it often manifests as wanting to play around with the newest tech, even if that technology is completely incongruent with the rest of your company's tech stack or project's tech stack. So if you are considering a rewrite and your eyes light up at the possibility of doing something completely new with an unfamiliar but exciting technology, then that's a moment to just take a minute and ask yourself, do I really need a rewrite, or do I just want a playground for new toys? Or to keep the analogy going, new kitchen for new desserts. So by now we've looked at the service in the context of the team and the team in the context of the organisation, and that brings us to looking at the service in the context of the entire application. The service is small and the scope well defined, or it can be broken up in such a way that this is true. So earlier we considered whether there are opportunities to improve the current code base as it is. And here we are looking at the suitability of rewriting the application in deployable chunks. And this is about minimizing the risk of wasting resources building something that never sees the light of day. In our case, our rewrite candidate was actually already pretty well defined. It was a stateless service, and it had a small, albeit important role in the context of the entire application. However, we still ended up with 3 deployable chunks. This absolutely was not a 3-2-1 big bang cutover. And if the application you'd like to rewrite is larger and more central to your system, then it's even more critical to have a plan on how you will break this rewrite candidate up into smaller deployable chunks. Having a small and well-defined scope for the rewrite is crucial so you can see the benefits of your rewrite as soon as possible. So, amongst other things, this reduces the risk of your project sponsors pulling the plug on the project. So, back in 2004, Martin Fowler was the first to coin the phrase strangler application. And as an Australian, I find this really cool, as Fowler was inspired for this metaphor during a trip to Australia where he encountered the strangler figs. And you can see one here at the right of this photo. So strangler figs are a parasitic plant that seed up in the upper branches of a tree, and they eventually make their way down into the soil. And in this process, they envelop the host tree, essentially strangling it, after which the fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. Paul is an ex-thought worker, contributor to Selenium, and strong voice in the team of chunk-based development and branch by abstraction. And before we discuss the image, here is the QR code to Fowler's original article, which you can take a picture of while I take a sip of water. Paul's blog also links to a couple of resources as well, including an excellent paper by Chris Stevenson and Andy Pulse. So the rabbit hole you can go down from Fowler's original article is really well worth it. So back to our image here. This shows a simplified evolution of a strangler fig web application. And of course, this is much harder in practice than in theory, but essentially you rewrite a small piece of the application and you run the rewrite alongside the original app. And slowly over time, as you rewrite more of the app, you route more and more traffic to the new app. And taking this approach makes it possible to weave in and deliver new functionality as you go, which can really help keep the stakeholders happy and build trust within the project. As an extension of that, it can keep the rewrite project alive. I'm sure we've all heard stories or experienced a situation where we've attempted a rewrite only to see it abandoned. Now, how you go carving out a piece of your application to rewrite will depend on a lot of factors, and it could be hard to know exactly where to start. So this is where a handy concept from extreme programming can be used, which is called a spike. So essentially, a spike is an experiment to explore a new solution to a problem. And it's so called a spike because it's end-to-end and it's very thin. So a spike can be functional or technical, but it's usually best to start with a functional spike. So identify a pain point for your users in the current application and build a proof of concept to tackle that pain point. Now, ideally, you would find this pain point from your users directly, and it's like bonus 1,000,000 points if you do, but it's also fine to have someone on your team act as a customer proxy to come up with this pain point idea. So in our case, our first users were the researchers at the customer, and together we decided the first deployable chunk would be a number of APIs so that it would be possible to interact with early versions of the item selection models. So the final application would actually combine 3 internal steps into one endpoint, but exposing the internals of the application early meant that the researchers could query the model directly, run simulations, and verify early that the model was in fact doing what we expected it to do. And if it didn't, then they could provide us with feedback. Now, Delivering this value early, even if it was not production ready, was really important in building trust and keeping the project going with the full support of the key stakeholders. And in addition to this, just keeping it alive, it provided us with invaluable information on how we would actually get our first chunk to production and what the scope of that chunk would be. So going back to our checklist now, when the question came up in our team of do we dare to rewrite, despite our strong bias against not rewriting, when we considered these factors, the answer actually became pretty clear. And I'm happy to report that not long ago we decommissioned the last instances running the old application, and we are 100% running the rewritten application in production. Pause for applause. Thank you. So I do think this is a really cool milestone, and I do want to share a little bit more about how we approached the project and what we did learn along the way. So the first step was an audit of what the current model actually did. And along with discussions with the customer, the audit included also meeting with the researcher that built the original model, simply just to learn more about what the app does and how it does it. And so on the slide here is just a brief version of the results of that audit. So the audit was actually really, really enlightening because we discovered how many features the app actually had and how few of them we were actually using in production. So for example, there was a feature called content balancing. And what that means is if you have questions or items from different topics in the same item bank, then you can make sure that an even number of questions from each item bank or category are shown to the student. Sorry, topic or category are shown to the student. So basically the model would determine which category needs to be shown next, and then of these items, which is the best item to show to the student to estimate their ability or to match their ability. But in production, we actually had a separate item bank for each topic, so we did not need the content balancing feature. So the customer did express a desire to use that feature in the future. So what we did was we added as a potential requirement for a future release, but we deliberately left it out of version 1. And this phase of the project was really, really interesting because we uncovered how powerful the original model was and how little of it we were actually using. Because had we uncovered all of these layers and learnt that we were indeed using all of them, then this would have been a really good moment to just go back and reconsider if a rewrite was actually a good idea. Because we remember point 3, right? The scope is small and well-defined. That's not just something you think about up front. It's something you need to keep in your mind as you go. Because I really think this is a huge trap for developers, especially if you've just joined a project, say within the last 12 months. And I actually think it's a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, ugh, why is this so complicated? If we could start over, simplify our data model, abstract that over there, and use some newer technologies while we're at it, well, we could move faster and enjoy working on the project much more in the process. But the truth about many production systems is that they are the way that they are for a reason. You are not smarter or more insightful than your predecessors. Sure, things do evolve over time, and decisions made in the past may be suboptimal given today's context, but often there is much more to architectural or design decisions than what is immediately apparent. So I would say that if you do decide to pursue a rewrite, treat the first phase as a discovery or a feasibility phase, even if you are writing code already. Prepare yourself mentally to walk away if things turn out bigger or more complex than you expected. So after a few meetings, we had an overview of the features and requirements for version 1, and it was decided that while the new system as a whole would be a drop-in replacement for the old system, the underlying statistical models would also change. And this was for a couple of reasons, one of which was to make the model more extensible in the future. So, for example, the old model used just one item quality parameter to estimate the student's ability, that is the item difficulty. However, under item response theory, there are at least 2 other parameters that can be used. And the other key reason for the change in models was, as mentioned, that there were features not being used at all. So the combination of unused features plus the desire for future extensibility led the researchers at the customer to decide to actually rewrite the underlying statistical models. And that decision did impact our approach to testing a little bit. In the end, it was the role of the researchers to validate their new model against the existing service, and then they just provided us a list of inputs and expected outputs that we could add to our test suite. And overall, it was actually a really, really nice collaboration as we both analysed the existing application code from different perspectives. So we at Trifork, we looked through the ends of like inputs, outputs, exception handling, edge cases, whereas the researchers were more focused on the mathematical methods and the psychometric validity of the model. So when we at Trifork were ready to start the development on the application itself, we were provided a model from the researchers, which was written in R and accompanied by mathematical notation. So this meant that the team could work on understanding the model in a way that was most natural to them. So personally, I preferred the mathematical notation, but there were members on my team that preferred the R code, but what was great about it was that we had the choice to go with the way, the representation that felt most natural to us. And really want to just quickly clarify that when I say we were handed a model, that actually happened in stages. It's not like the researchers, spent 6 months locked in a room and then just went, here, put this in production. So the researchers were fully aware that we planned to use Kotlin, and they did their own investigation of what libraries were available, and they discussed them with us. So as to why we chose Kotlin for this project to begin with, I hope you actually already have a couple of ideas as to why. So as I mentioned earlier, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter, it's what we do. In my team in particular, we have a strong preference for Kotlin. Believe it or not, I actually learned to program in Kotlin. So in my opinion, choosing Kotlin or Java in the context of a Spring Boot application is really little more than preference. Sure, your preference is wrong if you choose Java, but everyone is entitled to their own mistakes. So, wow, none of you left. So, good. The Dutch are always reliable for a sense of humour. So, as for the choice of Spring Boot, the downsides in this instance of the framework, namely the size and the startup time, they were just going to be a non-issue for us. Kotlin is a good enough choice, and Kotlin Spring Boot is a good enough choice in the context of our company and our team. So having made the language choice of Kotlin, and together with the researchers, we looked at the numerical packages available to see whether they would be a good fit for building the model. So JetBrains have been pushing Kotlin for data science a little bit, so we knew that there was plenty of options out there. And 2 options that came up in our search were Multi-K and Smile. So Multi-K is a multi-dimensional array library, and SMILE stands for Statistical Machine Intelligence and Learning Engine. Now, immediately, SMILE just seems way overpowered for what we would be doing. However, Multi-K was a solid candidate. So at Trifork, we went back and we did some small experiments. And what we found was that while multi-K would do a fine job, it actually didn't add anything extra for our use case. It made light work of calculations on multi-dimensional arrays, which we most certainly would be doing. But after a little bit more consultation with the researchers, we found that the arrays in the final model would actually just be two-dimensional arrays. Now, this is a really, really important distinction because two-dimensional space is actually pretty straightforward. 3+ is where it gets tricky. Because another way that you can think of a two-dimensional array is as a list of multi-parameter objects. And I'll show you what I mean by going through an example on the next couple of slides. So in Kotlin, we can simply define a data class of multiple primitive types. Now, this is a trivial example of sales at a waffle store. I just did this just to keep the domain as simple as possible. And the very first time I gave this talk, it was in Belgium, so of course it had to be waffles. I was going to tweak the example a little bit for a local audience, but the Dutch are represented here by the stroopwafel. And of course, it's just fun to blame Belgians for no particular reason. So if you don't like the waffle store example, you can blame Belgium. So let's say that you have two kinds of waffles for sale at your waffle store, Stroop and Belgian. And they're each for sale at a different price. And I know that I just came pretty hard for Belgium, but that's our, right as Dutchies. So, to be fair though, I have made the Belgian waffles more expensive in this example because they are more delicious. I know, I'm a trader, call the IND. Please don't walk out. Okay, so after you have the data for each of your products, you can then define the weekend sales of your waffle store as a list. And to upgrade this code a little bit, you can lean into the type system and you can define separate types for quantity sold on each day of the week, for example. And we use this value object pattern quite a lot. It means that you never confuse the sales of Saturday with the sales for Sunday during your calculations, as they are different types. The compiler will just tell you right away if you try to use a Saturday value where you should be using a Sunday value. And here, that distinction doesn't matter because the price is the same on both days. But this extra bit of type safety saved our butts more than a few times. Because to give you a bit more of a concrete example from our model, the item difficulty and the item discrimination are both doubles, and they are used side by side in the code base to determine which item is the best fit for the student at that point in the assessment. So by declaring them as separate types, we could be confident when we were doing our calculations that we were doing them on the intended parameter, and that helped us prevent, erroneous results and days of stress and kept our hair in our heads. So, back to our waffle example here, and continuing on, you can calculate the daily sales of your waffle store using the syntactically beautiful sum of function, and you end up with 105 euros of sales on Saturday and 94 on Sunday. Now, just for a quick comparison, let's have a look at how you would represent this calculation with the multi-K library. So the cool thing about multi-K is that it allows us to use matrix notation. So that would mean that we could speak the same language as the researchers. So we can represent the waffle data here by first declaring the prices of different kinds of waffles in a 1x2 matrix, then by declaring the daily sales as a 2x2 matrix. So on Sunday we sold 15 stroopwafels and 25 Belgian waffles, and on Sunday we sold 20 stroopwafels and 18 Belgian waffles. Then we find what's called the dot product of prices and quantities, multiplying the row of the prices matrix by the columns of the quantity matrix and then adding the results together. And doing that, we came up with the same result as the previous method, 105 euros sales on Saturday and 94 on Sunday. Now, you might have a different preference, you could be a psychopath, but for our team, using the features of the collection library on a list of type-safe objects, as we saw on the previous slides, was much more natural and appealing to us than manipulating two-dimensional matrices, as you see here. So sure, this is much more lines of code, but to me, this is much more readable and trends towards self-documenting. So indeed, it turned out that we could do everything with the Kotlin standard library, and the researchers' model was written in R with that in mind. They still use their two-dimensional arrays or matrices in their models, but we could easily rewrite those as lists of multi-parameter objects. And the experience we gained during our experiments with the multi-K library actually helped us a lot there. Now, this calculation here is quite simple. It's just a summation of the multiplication of integers. The final model, of course, was much more complex, but in the interest of time, I will spare you a more detailed explanation. I just want to give a shout out to the researchers, though, because while the maths involved in this was far from straightforward, they were actually able to come up with a valid solution using pretty straightforward mathematical expressions. Nothing more complex than some exponential, polynomial, and logarithmic operations, all of which came standard in the Kotlin math package. So this meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I think is really cool. And it also validated our choice to pick the stack based on what was good enough in the context of the team, rather than trying to find the best language packages for modeling item response theory. So for the last bit of the talk, we're going to do a hard pivot, all right? So it'll make sense, I promise. So I want to shift our focus a bit, and I want to use the last part of this talk to just shamelessly throw in some pictures of a cute dog while I reflect on taking my first steps into a leadership role as a junior developer. So one of the things that I really, really like about working at Trifork Amsterdam is that we don't have fixed titles or roles enforced. We like to focus on the individual, and if there's an opportunity that comes up that matches your skill set, have at it. So even though I only had a couple of years' experience as a developer when this project came up, I ended up taking a little bit of a leadership role in some areas. And spoiler alert, it had mixed results. So in my studies of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages such as MATLAB and Mathematica. And I am by no means a mathematical wizard, but it's a solid enough background at the time, was the most maths experience in the team. Adding to that, I've been working with the customer for about 2 years, so my domain knowledge was pretty solid as well. The planets had seemed to align. So having suffered mega imposter syndrome for the last 2 years, mostly fueled around my insecurities not having a computer science degree, I jumped at the chance to show off these different skills that I had picked up along my unconventional path to becoming a developer. And I came to these first meetings with much enthusiasm and lots of questions like, what model do you want to use? Where do you get this number from? How do we go about solving this parameter? Do you have a paper I could read? And to be honest, I was probably quite insufferable. But just like, an excitable puppy accidentally knocking over a pot plant with a stick that is much too big for her, got a little bit of a free pass, and most of my questions were answered. And even though I didn't understand all of the answers all the way through, it didn't matter. I could get my head around the basics. We had a probability function that we couldn't solve directly, but we could estimate iteratively using the boundary closure approach. And as I mentioned earlier, the customer was kind enough to provide a working example in R. Now, R is not a language that I know well, but given enough time and Googling, I could figure it out. I also had access to the service that we were replacing. Again, not a C++ developer, but taking my time and annotating as I went, I could understand enough to ask the right questions and get the right feedback and form a sound understanding of the domain. And it was absolutely pure joy for me, figuring out how to turn mathematical formulas and R scripts into production-ready code, the kind of joy you see in a dog when she plays with her favorite ball. And we are a small team, so in the beginning it was largely my task to put the proof of concept together. And that worked for a while, until it didn't. I was having so much fun that I just didn't include as many people as early as I should. And don't get me wrong, this project absolutely was a team effort, but the proof of concept was a pretty important chunk of the work, and I kept too much of that chunk to myself early on. I had documented some stuff, but what I hadn't documented was all the loose ends that I still had in my head, and what needed to happen before we could go to production. And well, it was a summer by now, so like a good European, I went on holiday. Now, I'm a firm believer that timing is everything in life, so you guessed it, while I was on holiday, external pressure started ramping up, pushing us to get the first deployable chunk into production. And all those to-dos that were in my head were still in my head, and only in my head, on a beach in Greece. And I came back to work, and it'd been a chaotic couple of weeks, apparently. And the worst part of this chaos was like a lot of the issues that my team faced were like non-issues to me. I was aware that they needed to happen. I felt awful. Sorry, guys. So yeah, that was a big lesson. Leadership is more than knowing what's going on and being available to answer questions. I don't like to assume that my colleagues don't know things. I know that my colleagues are smart as hell, and I don't want them to feel any other way. And I think this comes from my own feelings about my intelligence and my identity, that if I'm not smart, then who am I? But that philosophy is ultimately unhelpful and unfair to others. If people get offended because you want to keep track of the details, well, that's on them. So definitely, if I had my time over, I'd be proactive in keeping the lines of communication open within the team and set an example by documenting everything as I go. Even if it's just brain dumping in a ticket, as my Uncle Fred would say, better out than in. And one final note on this, because I think it's really, really important to hear, even if it's just from some rando up here on stage. Even though I did make mistakes during my first toe dip into leadership, I am happy that I did it. I learned a big lesson, and that's been invaluable to me as I organically take on more leadership responsibilities as I progress in my career. So, to wrap up, let's revisit the title of this talk. Are rewrites always a bad idea? Yell out what you think. Wow, I set you up because purely just based on the way that I framed this question, the answer has to be no, simply because there are no certainties in life and sweeping generalizations are always wrong, at least some of the time. So maybe the question is, are rewrites generally a bad idea? And here I can confidently give a resounding yes. But they can be a good idea sometimes. So in this talk, I provided you with the top reasons to entertain the idea of a rewrite. Ideally, all of them would apply to your rewrite candidate, but personally, I'd like to see reason 0 and at least 2 others. So, reason 0, so called because without this one, all others are irrelevant. There is a desire to functionally change the application. If you're not touching the application anyway and it's running reliably and securely in production, why does it need to be rewritten? Reason 1, there are no small steps to be found. You've determined the application does require some ongoing development, but the code base is in a state and there are no quick wins for your team to start improving it. The skills are not in the team and you do not wish to acquire them. In other words, improving the application requires climbing a steep learning curve towards knowledge or skills that the company does not need or does not want. 3, the service is small and the scope is well defined, or it can be broken up in such a way that this is true. This means that you can deliver value and get buy-in early, and the potential downside is small. Now, if despite the odds you've determined that your application is indeed a good candidate for a rewrite, then you can take some small steps towards that goal. Start by conducting a thorough audit of what the current application does and what you'll be rewriting. Keep it small and specific with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so be curious, not judgmental. Treat the audit as a feasibility study. If there is more scope or complexity than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you've already started writing code. Now, in our case, the application was more complex than we first thought, but that was in unused features, and the audit helped us make sense of this and get us to a bare bones 0.9 implementation. When it comes to the tech stack, make a good enough choice in the context of your company or team. Rewriting an application comes with enough risk as it is. Adding a completely new or unfamiliar technology into the mix is just adding another layer of things where things can go wrong. Add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point of your users. Put it in their hands. What do they think? Lastly, don't be afraid to step up and do something scary. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time.